All right, so like I said, these are new notes. We did the getting ready worksheet yesterday, starting unit 4. If you want a title, I'll write that down for you real quick. So we are working with arithmetic sequences today. And we'll get into what that means in just a minute. So go ahead, I want you to take a couple minutes and try to find the pattern of that list of numbers.
only goes into itself, right?
Say it again.
19 only goes into itself, right?
Right.
I found the pattern, I just don't know how to describe it.
What do you think it is?
Add that number to that.
You had, say it again?
You add that to
Oh.
add that to that.
That's not the pattern. It is a pattern, but that's not the one I'm looking for now. So remember, the pattern we're looking for is how to get from the first number to the second number to the third number to the fourth number. It's going to be the same a bunch of times. You might need a calculator. And you're going to need a calculator today, so if you need one.
I thought it was 2 separate patterns on front end and bottom.
It's added. It's either addition or subtraction. It's the fractions. Okay.
Okay.
Oh, sorry.
Okay. Calculator might help you out with this one.
Okay, so I got that. I just don't know what direction.
Okay, we're going from a fraction to a fraction to a fraction. So my hint will be you're gonna add or subtract something each time. And it's gonna be a fraction.
So would you add 2 next time?
Okay, but that's only taking care of the numerators. Remember, when we're adding and subtracting fractions, they need to have the same denominator.
Okay.
Makes sense?
Yeah.
Would that be correct?
Good, except I want it as a mixed number because these are mixed numbers.
Okay.
Yep, that's right.
I found that they just go up by 1.5.
Mm-hmm.
I don't know how to write that. Like, do I just write
You found it to be, what did you say?
like whenever you say 2 divided by 5, and then
1.5. Is that what you said? Right, it goes up 1.5?
Yeah.
Right, now I need that as a fraction because this is written as fractions.
Yeah.
So that's right, but now I need it as a fraction.
I know the denominators, but is the denominator the bottom one?
Mm-hmm.
Yeah, I know that goes up bottom.
Okay, we're going to talk about that too. All right, so I saw a few people who were on the right track. So, Zach, what did you get? Add 3 over 2. So I saw a few people with 1.5, which is correct. 3 over 2 is 1.5. But
Makes more sense.
since our sequence is in improper fractions, we want to write our answer as an improper fraction. Okay? So 1.5 isn't wrong, but it's not in the proper form. What, Jansen?
I thought you were like asking for like the top numbers.
No, the fraction to the fraction. Yep. All right. If the answer is 3/2, so that's correct. How did you get that? So who else? Zach got 3/2. Carolyn, how did you get it?
I started with like 19 over 10.
Okay.
And I subtracted 2/5.
Good. Yeah.
And then I did like 17 over 5 and subtracted 19 over 10
Why did you do it a second time?
to make sure it was consistent.
To make sure it was consistent. That's great. So with arithmetic sequences are a list of numbers that go up by a constant pattern or go down by a constant pattern each time. So does everybody agree that that is an example of an arithmetic sequence? Okay, so it goes up by 3 over 2 each time. Carol proved a good point when she said she did 19 over 10 minus 2 over 5. But then she said again, what else did she do? Or 17 over 5 minus 19 over 10. Does anybody know what those kind of numbers are called? So when you have numbers that are coming right after another, what is it? Consecutive terms. So we need to make sure, I'm going to use that term a lot today. So consecutive terms, when you're looking at your sequence, are terms that are following one another. So 2 fifths, 19 tenths. 19 tenths, 17 fifths. 17 fifths, 49 tenths. Okay? All right, let's try to see if we can actually write a formula. Okay? Before we do that, I'm going to give you some notation. It's going to be new, so make sure you write it down in your notes. So the first thing is a sub n. Has anybody ever seen or heard of a sub n before? Okay, so it's all new. That's fine. A sub n is a fancy way of saying the number n term. Okay? And that sounds confusing right now, but give it a second to sink in. So the number n term. Or you might hear me say the nth term. When do we use variables? So what's the purpose of a variable? Right, when you don't know what's supposed to go there. So the nth term is just saying this is some number term, but I'm not sure which one yet. Okay? So let's try an actual number. So if a sub n means that, what do you think a sub 1 means? So a sub n is the number n term.
1.
N equals 1. So what term are we looking at?
The number 1.
The first term. Okay? So if we go back up to this example, what is a sub 1?
2 over 5.
2 over 5. Okay? So the first term. Let's see, what if I ask you what is a sub 4? It's the fourth term, and in our example it's
49 over 10.
49 over 10. So you just go to the beginning and you count 4 terms out. Okay, what is the fifth term? What would be the notation for the fifth term? A sub 5, and what would be the value? 32 fifths. You guys got it. Great. So the next thing I'm going to do is I'm going to give you a formula for how to find the difference. Okay, how to find that pattern. Because as you can see in that example, it was kind of hard. Some people were pretty stumped. But can somebody tell me before I give you a formula in words what you do? So remember, we use the term consecutive. How do you find that pattern? What do you subtract? The second number by the first number, or
The number before.
so you take consecutive terms and you're going to subtract them some way, right? You have the right idea. We call that pattern the common difference, okay? And it is notated by the variable d. So in this example, our common difference was 3/2, right? That was our pattern. The reason I'm giving you this formula is because on the EOC, you will be given formulas. It's great. And that way, if you see it, I don't want it to be the first time you've ever seen it. But if you know how to get it, you don't have to use this formula, okay? Because it's going to use a lot of terminology. Sometimes it can get a little confusing. So it is a sub n plus 1 minus a sub n. And we're going to break that down real quick. So let's say I tell you to use n equals 9. Okay? Let's write the formula for D. So if I say n equals 9, what's the only thing it's telling me to do? Okay, so plug in a 9 for n. So I should have a sub 9 plus 1, which is 10 minus a sub 9. Isn't that what Courtney was telling me, kind of in words? She said, you go take the terms that are next to each other and subtract them. Isn't that what just happened right here?
Yeah.
9 and 10 are what kind of terms? Consecutive. And now here's the key point. You take consecutive terms and you're subtracting right from left. So you go 19/10 minus 2/5 from our original example. So when you're doing that difference, if I were to do 2/5 minus 19/10, I would get the opposite of my actual answer. I would have got minus 3/2. So you have to make sure when you're doing it, you subtract right to left, okay? And that's all that's saying right here. Let's put it to use. So everybody got that written down? Okay. All right, so there's the problem. 3, 7, 11, 15, and 19 is your sequence. I want you to find a sub 1. I want you to find D. And I want you to find a sub 7. Good. Mm-hmm. Which one is? Which one? A sub 1, D, or A sub 7? So you, good, yeah. So remember what each of those mean. Nice. Do you need a pencil? Good, that's right. Now remember your D, what does that represent? That's our pattern, right? So how do you get from one term to the next term? Okay, so that'd be your pattern.
Oh.
Okay, good. You can put +4, that's not wrong.
Okay, so I'm also on the 9 and 1 again.
You're lost on how, I just told you, let's say n equals 9. It was just an example.
Okay, so what do I use on this one? Do
Well, you can pick any of them.
so I can use 3?
Any consecutive terms you want.
Okay.
So pick me 2 consecutive terms. Doesn't matter which ones.
3 and 7?
Sure, 3 and 7. And remember, you subtract, do you go left and right, or do you go right to left?
Right to left.
Right to left. So you would do 7.
Plus 1. So 3, so 7.
7 minus 3. Mm-hmm, good. All right, a sub 1. I don't want to know the number, not the value yet. What does a sub 1 mean? The first number or the first term? So everybody, I think I saw everybody write this one down. What was a sub 1? 3, very good. So all you have to do is go to your sequence and look at numero uno. So 3. D. What does D stand for? The common difference, or your pattern. So how did I get from consecutive term to consecutive term?
+4.
Add 4. How could you get that if it wasn't as easy to see?
7 minus 3, 11 minus 7.
Right, look at two consecutive terms that are right next to each other. Right minus left, okay? And Courtney wrote down +4 at first, and then she erased it. If you want to write your sign every single time, there's nothing wrong with that. If you want to write +4, if it goes up 4, that's fine. If you, obviously you have to write -3 if it goes down 3. But if you want to always write your sign for good practice, I'm never going to count you off for that.
Will it always be subtraction? Like, you always gonna be like, subtract that, or is it like?
To find the difference, yes, it'll always be subtraction. Common difference, remember, what operation goes with difference.
Yeah.
All right, a sub 7, what does that mean? The seventh term. So really you could have just started from 3. 1, 2, 3, 4, 5. How do I get to 6? Add 4, so I'd be at 23. Add 4 again. So you should have got 27. Very good. Any question on that part right there? So finding the first term, finding your difference, and then if I give you a random number that's kind of low, you'll be able to find it. Yep.
Could you get like a to like the negative one?
Can you have a,
Could you go back? Like, so 3 is your first term, and then you would just.
if you have a first term, could you have a term before it?
Yeah. If you did the opposite.
If it's the first term, could you have a term before it?
Yeah.
Then it wouldn't be the first term, would it?
Well, I mean, like, 'cause you could do 3 minus 4 and get -1.
Right, and that, I see what you're saying. I see what you're saying. So you mean, you could do 3, what was your example? You could do 3.
Minus 4 and get -1.
That's what you're saying. You're allowed to have sequences like this.
No, she's not saying that.
That would be 3 minus 4.
No, she's not saying
No,
that.
I meant like.
On this
There's
example.
a
For
4 in
this
front of the
example, like, the difference is 4.
Yeah.
So the difference between, like, if you do 3 minus 4 is -1.
It would never ask you what a sub 0 is, or like a sub negative. It won't ever ask you that.
Okay.
No, it won't ever ask you that. The first term, it's always a sub 1 and up, because the first term is always, no matter what it is, it's always going to be labeled a sub 1. Okay? All right. We're going to take it a little further. Who in here wants to add 4 over 100 times?
Nope.
Me and Tanner. Okay. All right, and Josh. Everybody else wants a new way. Okay, well, I'll give you one. Go ahead, Courtney.
Well, wouldn't you just do 4 times, like, no.
You just hold on to that.
Okay.
All right, so before we start adding 4 a bunch of times, since it was just me and 2 other people, nobody else wants to do that, I guess we'll try to figure out a different way. So I'm just gonna start out with a chart. Kind of help us organize our thoughts. We're gonna start at the very beginning. What's the first term? How do I write that in proper notation?
A sub equals to
A sub 1. Good. That's the first term. What was the value of a sub 1? 3. Okay. What would be the next term? A sub 2. How did I get there from the first term? You added 4. I'm going to write it out like that in purposes for you to look at the pattern. So 3, our first term, plus 4. What's the next term? A sub 3. How did I get there from the second term? 7 plus 4. I'm going to write it all out, though. 3 plus 4 plus 4. One more for good measure. A sub 4. Okay. Now, sure, I could keep writing this chart all the way to a sub 50, but you guys told me you didn't want to do that. So, what I want you to do People, I already see light bulbs clicking. I want you to take a couple minutes and I want you to figure out the pattern. If you get the number, that's great, but you need to know the math behind it, okay? So I want you to figure out, if you figure out an equation that you can type in your calculator that will give you the 50th term. So that's what we're doing right now. See if we can pick out the pattern. There will be multiplication. See if you see a pattern between the term
I see you keep
and what happens in the. Okay.
That's what I see.
What do you notice? What happened? How many 4s do we have in the first one?
None.
None. How many terms do we have in the second one?
One.
So that's the second term, 1 4. What about the third one? 2. What about the fourth one? 3 4s, right?
This would be 3 with 1.
So from here, what do you notice about these, the number that's over here versus the number that's over here? So think on that. See if we can come up with something. Good.
I just think because every time you always have a 3, but there's also 100 terms, like, so you have 99 numbers in one.
Does this work like you do 4 times whatever you're trying to find and do minus 1? Because I found that for all those and then I tried it for the 50 and 100. But she did a different way.
It doesn't always work like that.
Okay, so I figured it out because like you always have a 3. When you have 100, on the 100th, you always have 100 terms. So you do 4 times like 99, because that's your second one, plus 3.
There you go. All right, so I don't want the number, and I don't want your equation yet. I want somebody in words to try to explain what pattern I was talking about. Shelby.
Okay, so when the value is 1, then it's only 3, but when the value is 2, it's 3 plus the number you're going up by.
Okay.
So when the value is 5, it'd be 4 of the values that you're going up by and 3.
Good. Okay, so she's got the pattern. So what she said is you start here. I'll break it down. So in our first term, how many pattern numbers did we have? So how many differences did we use? None, right? There's no 4s in A1. So we used 0 4s. What about in A sub 2? We used 1 4. What about in A sub 3? We used 2 4s. What about in A sub 4?
3.
We used 3 4s. So what do you notice about the number of the differences that we're using versus our term? It's 1 less. There we go. That's the key term right there. It's 1 less. So if I want to find my 50th term, how many times am I going to add 4? 49 times. And then what's always in the beginning? Plus 3, because that's our first term. How do I write the 50th term in proper notation? A sub 50, good. And you guys told me 3 plus, I'm going to multiply, I'm going to write it out. So 49 times 4. I'm writing it out so you can see where it's coming from. So what should the answer be?
199.
199. Now, using that information, if you haven't already, I want you to get me the 100th term. Using a minute. Give everybody a minute.
Can you just times it by 2 or not?
Nope. Not that easy. Do you have a question? Question? Mm-hmm.
Why wouldn't the minus 1?
Okay, so let's look at A1. How many 4s did we have? For A1, 0. How many do we have for A sub 2?
Oh wait, 1.
1, 4.
Yeah.
How many do we have for 3? 2, 4, 3. So do you see how, what the number term we have? We have 1 less
Yeah.
4. So if we want the 50th term, how many 4s are we going to use?
49.
49, because it's 1 less.
Yeah.
Make sense?
Yep.
Okay.
What's this new equation?
What's T?
That?
Mhm.
The term you're trying to find. So like the 50 and
N. N.
N.
Mhm.
What would that be?
Yes.
Could it be written like that?
Not for arithmetic.
Okay.
So yeah, not for arithmetic. You're too far ahead.
I thought it was pronounced arithmetic.
They're spelled the same way.
Yeah, I thought that would be
Arithmetic.
I've had that argument all day. It's arithmetic, Miss Kohls, but this way it's pronounced
Arithmetic. What do you call it?
arithmetic.
Arithmetic.
I feel like you're on a TV show with a microphone.
Yeah. All right. So what is the proper notation for the 100th term?
A sub 100.
A sub 100.
3 plus 100 minus 1.
Very good. So 3 plus 100 minus 1 times 4. Does everybody see how we got that equation? Good. Okay, so what should we have got? What should our value be? 399. So if I start here at 3 and I count out 100 terms, 399 will be there at 100. Okay? The last one, the nth term. Does anybody have an idea of what our nth term is going to look like?
You just put it in.
Are you saying
Say it a little nth, like the 6th. I know, it's a little weird to say. Okay, so Caleb, say that a little louder.
You just put an N where the number would go.
He's saying, okay, so you just put an N where the number will go. So why is it nice to have the nth term? What could you do with that if you're going to have an N wherever your number is? All you'll have to do is enter a number. So the nth term is going to give us an equation where we can just enter any number we want. So I want you to take a second and see if you can write that nth term, like the equation, for this specific example. That's next. You did it. You did a general one for any example. Perfect. Equals, not n though, it equals a sub n. Makes sense? You're not going to get a number until you plug in something for n.
Okay.
Okay? Good. Mm-hmm.
Oh, wow.
Nice. Okay, so what should our notation be for the nth term? A sub n. So A sub n. And if we do what Caleb told us to do, all we need to do is put our n where our term value was. So you should have got 3 plus except it's 4. Sorry. So that's a 4.
So say you had an equation like that,
Mm-hmm.
but we only had the first term. Like we have an equation like that, so say you'll give us 3, 7, 11, 15, and 19,
Mm-hmm.
and then you put that equation up. You just have to put in like.
Yeah, I'd like, so you would use this in the case if I gave you this equation. The question would be, find the 112th term. And you would use that equation, and you would plug in, what would you do? Right, plug in 112 every time you saw an n. Okay? So did everybody hear that? Shh. All right. One last thing before our activity. Does everybody, let me jump back real quick. Does everybody see how this is great, But it only does it help us for any example? No. Why?
Because we're not always multiplying by 4 or adding 3.
Right. This isn't always our first term. This isn't always what our pattern is. So I want to write an equation that I can use for any example. Courtney, I'll call on you, I promise. But I'm going to give everybody just a minute. I want to write an equation that I can use for any example. Put it away. So any example. What is that? Oh gosh. Any example. Good. Perfect. Well, watch it. You're just missing something. What did we do with the 3?
What? The first.
You're missing an operation.
Plus.
Show me.
Is this right?
Good. Yep. Wow, pretty impressed. People are rocking it out.
I would get the answer, but
Good.
Andy sent some next to me.
All right, so I'm going to go back to our definitions page. So that formula that I just saw lots of people get correct, it's got a special name.
I think I wrote the calculator.
It's called the explicit formula. You'll hear me use that term a lot. It's called the explicit formula. The explicit formula is a formula that you can use to find any term of any sequence. Okay? So let's see who had it. Tyler. Oh, Courtney. I know, I promised you. Okay, Courtney.
A1 plus parentheses n minus 1 parentheses times by b.
Good. And how should we notate it? So, A sub n. Very good. And everybody can fill out these equations. You guys did it in the very beginning, right when we were first getting terminology. A sub 1 is what?
First term.
The first term. So all you have to do is go to your sequence and look at the first term. N is what? The number you're trying to find. So if it says find the 10th term, N is 10. Find the 75th term, N is 75. And D is the common difference, your pattern. Okay? Awesome. All right, so you are going to want to leave your notes out probably, because this will involve using them. So I'll explain what's going to happen as I pass these out. On your card, you're going to have an answer and you're going to have a question.
Oh, we gotta find the person with it.
We're going to just do it as a class. But yeah, you have the right idea. So what'll happen is I will start off by calling on somebody who has a number on the top of their card, and they'll read their problem. Yep, just one. Once they read their problem, everybody will go and answer it. And then if you have the answer, once I ask for it, we'll check it out and see if it's correct, and then you'll read your problem. And it'll just go in a big circle. I have a bunch up here because we have some people absent, so I might have it. Put that away. Okay, so who has the number 12 on the top of their card? Number 12. Jade's starting us out. So just read your problem and I'll write it up here.
Okay. 5, 7, 9, 11, 13.
What's the question?
What is D?
What is D? So Jade was given a sequence. You need a card, Josh? Jade was given a sequence. She read it out. And now it's asking what D is. So yeah, some people don't have a number. That's okay. So everybody's taking a second. You need to find D. So you can write this in your notes or you can do it on a separate sheet of paper. We're doing participation grade right now.
Write all of them.
You don't have to write the question, just write the answer.
Oh.
Yeah. You don't have to write the question, you just need to work it out.
Wait. Do we have to show an equation for this?
Nope, you can just do it in your head. Yes. Yes, you may. Take the pass. All right, what do we think it is? 2. Let's see. How do you get that? So if it wasn't as easy to see, what did you say, Tanner?
7 minus 5.
7 minus 5, or
9 minus 7.
9 minus 7, or 13 minus 11. Any consecutive terms, right minus left. I had that card, so. All right, here's the next problem. A sub question mark equals so what term did the question ask us to find? So we were given this hypothetical question and it said find this term. What term was it?
18.
19.
17.
Take a second and think about it.
I think I know how to do this.
Oh wait, it's my.
Take a second and think about it.
Why are you writing the answers then?
Some of them will require a little more work. All right, who thinks they have the answer on their card? I got 2 people raising their hand. Who thinks they have the answer on their card? Tanner thinks he's got the answer. All right, why is it 19, Tanner?
It's, you do one less than the thing, and it's 18.
Right, okay, so this part right here, this parenthesis, comes from n minus 1. So this right here is what? Question mark is supposed to be, right, n. So n is 19. Good. All right, Tanner, read us your question.
Negative 17, negative 12, negative 7, negative 2, 3. How many terms are in the sequence?
Like I said, we just got to cover all of our basics. We got to make sure we get all the building blocks before we move on to the more complicated stuff. So how many terms are in that sequence? Who thinks they have it on their card?
Jansen does.
Do you have it?
I don't know.
He does.
All right, Jansen's got it. 5.
Oh,
Why is it 5?
that's what we are looking for.
So the question was how many terms? Why is it 5?
Because there's 3 right there and then 2 more.
Right, it's literally asking you to count the terms. There are 5 terms, okay? All right, what's your problem?
Oh, crap. AN equals 1 plus parentheses n minus 1 parentheses 5. That's, I don't know if that's
Thirds or halves?
5/3.
What's it asking us to find?
What's the 7th term?
Okay, so you're given that equation, and it says find the 7th term. So here's one that requires a little bit more work.
Sorry.
Anybody need a calculator? We should all have one. Tyler. The biggest part, remember, we got to make sure that we can put these in our calculators correctly.
Wait, Ms. Kohls.
Order of operations.
Do we just put the 7 into the end?
Mm-hmm.
Who did I click
No, I'm looking for the answer. Question? Good. Yep. Nice.
How do you do this? How do you,
So you do,
like, how do you multiply the fraction?
right, 6, put in your value, parenthesis, 5 divided by 3.
Why did you say somebody else?
Okay. So it's all.
All right, who thinks they got it?
Katie.
Oh no, my card.
Katie, what's your card say? 11. Why is it 11?
You're asking
Yeah, tell me what you did.
where
Uh-huh. Good. So 7 minus 1, 6. 6 times 5/3. 10 plus 1. 11. So she's correct. All right, what's your problem?
What do you call terms that are next to each other?
What do you call terms that are next to each other? Who thinks they have the card? Thomas. Consecutive. So terms that are directly next to each other in a sequence are called consecutive terms. Good. What's your problem?
1, 1/4, negative 1/2, negative 5, 1/4. What is D?
What is D?
What's D?
Oh.
D is a letter now.
So what is D? Good. What is D? So you need to find the common difference. All right, who thinks they got it? Josh, you think you got it. How? Well, first, what's your answer?
Negative 3/4.
-3/4. How did you get that?
1 minus 1/4. I mean, 1/4 minus 1.
Good. So he found 2 consecutive terms. Right minus left. So 1/4 minus 1. Which, if you did that in your calculator or if you did it in your head, -3/4. He's correct. All right, what's your problem?
How do we define the nth term?
How do we define the nth term? Or what is the notation for the nth term?
Huh?
What is the notation for the nth term?
Oh.
Not the equation, just simple, how do you define it? Like, how would you write it? Yep. Give everybody just a second. All right, so Zach, what do you got? A sub n. So the equation is the nth term equation, but it's just asking how you would write it out in notation. So just A sub n. All right, what's your problem?
A sub n equals 8 plus n minus 1 in parentheses, and then -4.
-4?
Yeah. And then what is the 10th term?
Okay. So you're given an equation, and you need to find the 10th term.
No, I'm using a calculator.
You can type it when they're saying it. There, you can practice. Type it in your calculator and see what you get. All right, Carol thinks she's got it.
-28.
Okay. How did you get -28? Walk us through it.
I plugged 10 in for n.
All right.
And 10 minus 1 is 9.
Okay.
And 9 times -4 is -36.
Good.
And then plus 8 is -28.
Beautiful.
I don't know what we want.
All right, she got it. What's your problem, Carol?
What do you call a list of numbers that have a common difference?
What do you call a list of numbers that have a common difference? Arithmetic sequence. So that's the definition of an arithmetic sequence. A list of numbers that have a constant pattern. All right, what's your problem? How do we define the first term? Shh. Hunter Dan.
A1.
A sub 1. Yeah, go ahead. So A sub 1 is the first term. I have that card, so I'll read the problem. 10, 7, 4, 1. Find the 11th term. So this might be a good example where you try to plug into the equation. So we have an equation that works for any example. This might be when you want to try to use it. The 11th term. Good. Deal. It's good notation. Shh. So how do we do this?
You keep subtracting by 3 to get to negative 12.
Okay, you can do it that way. But what if it said the 99th term?
Keep subtracting by 3 to get
My
to
goodness, that's going to take you a while.
I would do.
We'll practice it tomorrow. All right, who thinks they got it?
Oh.
Who thinks they have the card?
If you have a negative 12, raise your hand.
What do you think it is? Negative 20. That's, nobody has it because I have it. So let's look at it though. So we're looking for the 11th term. If I wanted to use the equation, how would I write it? So Courtney, how would I start it?
Can you ask him to cut that from
It's
the video?
a to the 11th.
Okay, a sub 11
And equals 10 plus 11 minus 1 times negative 3.
Perfect. So if you plugged into the equation, that's what you should have put in your calculator. She plugged in 11 for n, her first term, 10. Her pattern was subtracting 3 each time. Awesome. So negative 20. All right, here's another one. It says a sub question mark. So we've had this kind of problem before. Negative 2 plus 20 times negative 8. So what term are we looking for? Yes.
Paper sucks, but these almost match this.
Okay, I'll take them. I'm getting, yeah, thank you. I think you got it. All right, Hunter Dan thinks he's got it.
I know I got it.
What's your card say?
21.
21. Why do you think it's 21?
Because
You gotta tell me why. Just get lucky?
it's n minus 1.
What is?
Like this is like
Where's the n minus 1 go? Give me a value. Right here? So this should be n minus 1. So if I do n minus 1 and get 20, n has to be 21. So he's correct. All right, read me your problem.
what is the equation for big A?
What is it?
Arithmetic.
What is the equation for an arithmetic sequence? So what equation should we use for an arithmetic sequence to find a term? Okay, what's the name of it?
Explicit.
The explicit formula. Who's got the explicit formula? Tyler's got it. All right, good way to end. Pass up your cards. Bell's about to ring. Time flies when you're learning.